Let's get started with today's recap. So, what have we learned so far? In these first 4 days, we've covered 3 new languages, an entire front-end library, using APIs, servers. I think we could have done it in 1 day. So we're going to go through everything we did in just 30 minutes. In all seriousness, you might think you're completely lost. And that's okay, because I really think that with a little bit more practice, you will really start to get hang of the concepts we've been teaching you. And to demonstrate this, we're going to play my favorite game, scream out the blanks to the sentences. So websites use the, yes, JavaScript. If you answer Julia, feel free to leave. We divide our app into React components. Each of these components is a function with props as input and can store internal, updatable private information as state variables and returns HTML-like code. Props pass down from parent components to child components. And finally, websites have a front end and a back end where server lives to handle API calls. Okay, so quick recap on the 3 web development languages. We have HTML, which is the organization and the content of our website. We have CSS, which is the layout and styling of our website. And then finally, we have JavaScript, which is the interaction. I think before we use a bit of a body analogy. So in this analogy, HTML is the skeleton or the bones of the body. CSS is the skin of the body, so you can look great. And JavaScript is the meat and the muscle. So you can actually, do things and not flop around like a dead fish. Next, we have a quick recap on React. So React is really useful because it allows you to really structure your web development code into different components. So here at the top level, we have our app component. We have 3 child components, the feed, the profile, the navbar. And then the feed has 2 child components, card and link post. And the great thing about React is it allows you to reuse your components again and again and again. And so, for example, we can have an arbitrary number of cards in our feed to, account for a feed that grows longer and longer and longer. And this is really useful. So we're going to be going through a quick walkthrough of this small piece of React code, just to refresh your brains. So at the start, we're defining an example functional component. And this is going to be a function that takes the props as input. Again, the props are what the parent is going to be giving to this child. And its output is going to be a bit of HTML. Down here, we're exporting our example so that other components can see this component and so that they can use it. Next, we have a bit of state. Use state is an example of a React hook, and we're creating a state1 variable as well as a set state1 function so that we can actually use our state. Now, you might be wondering, why do we need a set state1 function? Why can't we just set it directly or, using the equal sign? And there's really 2 really useful reasons for this. As you can see down below, even though it's not highlighted, we have state1 being rendered in the HTML output. And so if we use the set state1 function, it sort of triggers React and tells it, hey, we need to update the view. If you were to just use assignment, first of all, it wouldn't work because it's const, but ignoring that problem, if you were to just use assignment, it wouldn't tell React to update the view, and people would just be seeing a static website. So by using set state1, we can actually update our view. And the other thing is by using state variables, they're going to persist even if the component has to be reloaded. So remember that props are passed from parent down to child. And so if the parent changes the prop, the child component is going to be rendered again. And when this happens, the entire function is going to run again. And so you might think that state one will go back to being the value one. But because it is a piece of state, it's not going to be reset. And so if we were to use set state one to be like the value 100, and the component was re-rendered, it's going to stay at 100, which is useful because you want to have persistent memory. Okay, next thing we have our use effect. So this piece of code, we're passing in a function to use effect and then an empty array. And what this means is that this function that we pass in as our first input is going to be run after the first appearance of the instance in the component. So as soon as our component is rendered, as soon as it appears on the screen, roughly speaking, our function inside is going to run. And why is this useful? Well, you might want to make different API calls in here. You might want to do different things in here. And anything you want to do on startup, you can do in this function that we passed into use effect. Now, my question to you guys is, anyone remember what the second argument is doing? Why are we passing it an empty array? Does anyone remember? Okay, so this part was a bit in detail, but the second argument to here is called the dependency array. And to sort of explain this dependency array, I'm going to explain what happens if you were to pass anything at all. Let's just pretend we only gave it one argument, the first function. If you only give use effect one argument, that function inside is going to run every single time the state or the component is re-rendered. So as soon as a single change is made, the component might re-render and that use effect thing is going to run. Now, sometimes you only want to use effect on certain cases. And that's what the dependency array is for. So when we make it empty, we're saying we only want to run in the certain case where we actually don't want it to run anything. If we were to give it like a prop, like prop data from parent, our use effect hook would run whenever prop.data from parent is changed. So if you ever are wondering why we have this array, just remember it's a dependency array. And finally, we have our return statement. We do need to return something, and we're going to be returning the actual HTML code or the structure for our component. So we have a div, and it has two divs. And the great thing about React is that you can mix HTML and JavaScript to make your code cleaner. So here we are using the curly braces to embed the state one variable, as well as a props.data from parent. Okay, now another quick recap. So what is a server? The concept of a server, it might be a bit confusing. Just remember, a server is just a computer somewhere that's running code. When you're developing code, the server is actually just running on your own laptop. It's as simple as that. And the purpose of a server is to provide services for clients. So you might have a client, and all it does is the client is going to make a request to your server. A request is just some data. And depending on the protocol, you might have to be structured in this ways, but at the end of the day, it's just data. You're going to send data to the server, and depending on what the data is, the server is going to send data back to the client. And that's all a server is. It just does something for the clients. It serves them. A great thing about this client server model is that you can only have one server, but you can, service a lot of different clients. And so this is pretty useful because if you had, let's say you were Facebook and you had like 100 million users, you don't want to have like 100 million servers, one for each client. That would be really expensive. So each server can actually service multiple clients. And you might be wondering, why do we need a server in the first place? And there's several different reasons. So the first is file access, right? So like imagine Facebook, right? Facebook probably has like hundreds of terabytes, maybe petabytes of data, right? But each client doesn't need all of this data, right? Each client only needs a tiny margin of this data, a tiny fraction. And so by using a server, we decrease the amount of storage space needed for the client. The client only needs enough storage for what it needs to display to the user, whereas the server is going to have terabytes maybe of data. The second reason is centralization. In many cases, it's really useful to have a single authority be the ground source of truth. And what do I mean by this? So let's imagine you're playing a video game, you're playing an FPS, and sometimes you lag and you die. And what happened here? So the thing is, sometimes what you see on your screen and what someone else might be seeing on your screen is actually going to be different because of lag, because it takes time to send data and get it back and whatnot. And if every single client was like arguing about who actually died in like a video game, this would be really annoying, right? And it wouldn't be fair to any one of the clients for them to be the source of truth. And so this is where the server is going to step in, and whatever was recorded on the server in this hypothetical video game is going to be the source of truth. And again, this sort of explains why you might experience lag in some video games, and then you just end up dying. And the final thing is security. First of all, it's just a lot more secure to be able to protect one server than every single client. But there are also lots of cases where you want people to restrict information. So like imagine I'm using a social media app and I upload a profile picture. But let's say I have like only like 10 friends, right? If that picture was available to every single client, that would be a problem because I don't want every single person in the world to see my profile picture. I only want my friends who will see my profile picture, right? And so this is where a server can be useful because it can restrict information depending on who you want to give access to what information. Okay. So quick recap on HTTP. So HTTP is a way to communicate on the internet. So remember before our clients were sending data to the server? Well, HTTP is just the way you structure this data so that the server can make sense of it. And usually you want to be using two different types of requests. You want to use GET requests to ask for information, and you want to use POST requests to add the information to the server. And we commonly use HTTP to interact with an API. So this quick question, does anyone remember what the other types of HTTP requests may or may not have been? Yes, there's a put, delete, there's also patch. But if you don't remember, you don't need them. So it's okay. Now, we're going to be moving on to APIs. So what is an API? An API, it may sound really fancy, right? Application, program, interface. It's like, what, 25 letters at least? It's just a set of rules, right? And an API is just a set of rules that describes how you access data from a server. And the different API endpoints are just the various functions that you call. So when you're programming, just remember that an API is basically, at the end of the day, it's just a function call that you can make that's just across the internet. Like, you imagine writing like a Python function, it would just run on your own computer. Now you can imagine it's a Python function that's sort of running across the internet. So we have, let's say you could have a get pet / pet ID API call. And you can almost imagine this being like a Python function, right? Like get pet by pet ID. And it might be producing this output. So we have our ID, we have some category, we have a name. And again, API is just a set of rules. So an API is describing the output that you would get from sending this get API request. Finally, JavaScript is an asynchronous programming language. And what this means is we cannot wait for an API request to complete before executing more code. And what do I mean by this? So, imagine I'm in the web lab lunch line, right? It's going to be like 5 minutes until I get my food. Let's be honest, I'm not just going to be standing there like moron, right? I'm going to pull up my phone. I'm not just going to be standing in line. I'm going to be doing other things. And this is the same thing for code. You don't want to just be waiting for your API request to complete, right? You want to be up and about. You want to be doing other things. You want to be updating the front end. You want to be displaying more information to the users. You want to be making other API requests. You cannot afford to be waiting for 5 seconds for your API to return information. And this is why we want asynchronous programming. So, quick question. Does anyone know what this is going to print out? Sure. Unknown. Yeah, so not quite. So it's probably going to print out unknown, but we actually do not know for certain what is going to print out. So it is unknown, but not the string unknown. The reason happens really quick. Yeah. The reason for this is probably what's going to happen is we're going to make this get call and then we're going to skip to the console.log and it's going to print unknown. But it's possible that our API is going to run like blazingly fast. We have the fastest API in the West. And if that happens, it's possible that our promise is going to resolve faster than our console.log. And we can actually set pet name to the pet.name. And it's going to print out Labrador. So now that we have more of the motivation behind asynchronous programming done, we're going to be going through promises. So a promise is a guarantee that at some point our unresolved return value, it's going to become something, right? It's either going to be a valid response, which is what we want, or it might end up being an error. But it's telling our code, hey, at some point, this is going to happen. It's either going to be valid or it's going to be an error. And asynchronous functions like get all return a promise. And in order to act on that promise, we use the .then syntax, which is we're going to be walking through next. So here we have a get API call, the endpoint add one. We have some input. And remember, at this stage, all we have is a promise. That's all we have. In order to do something with that promise, we need to use a .then. So we had a .then, and the input to the .then is a function. The function takes as input 6, and it returns something. And this might be confusing if you aren't used to, nesting functions like this or giving functions as input to functions. But I think with a bit of practice, you guys will get the hang of it. And what this means is that whenever our API resolves or returns a response, it might take a second, it might take 10 seconds, it might take a minute, it might take an hour. Whenever our API finally gives us a response, then we are going to run our function, the one that we pass in as input. And again, it might take a really long time, but when it does, yeah. So variable 6, like the output. Yeah, so here 6 is the result given to us by the API. And I guess right now we're just assuming it's just going to be a number, but in general, it could be a string, it could be JSON data, it could be anything. It just depends on what your API is. One of the cool things about the .then syntax is that you can sort of chain them together. So if we have a .then, then we can add another .then. And the second .then is going to run the second dot then is going to run only after the first dot then has run. And so actually what you could do is you could make the second dot then another asynchronous function, possibly. Or actually take that back. But this second dot then is going to run only after the first dot then has run. And finally, we can add a dot catch, which is an error handler. And so what this means is our error handler is going to run if at any point in the previous 2 or 3 steps, if it throws an exception, we can catch that exception. So specifically, if our get function or get API, if that throws an exception, we can catch it in the error handler. Right now, our 2 functions that we pass into .NET are really simple. But imagine they were like 100 lines long. You could presumably throw an exception in there, and then we could catch the error. Yeah.
So could you add more .ends after the first 2?
Yeah, so you could add as many .ends as you wanted to.
So these are basically these are there's no difference with the order.
The order, no, the order does matter.
But other than that, they're
yeah, there's no difference, but they will execute in the order that you specified. They're not going to execute in whatever order you want, or they're not going to execute in some arbitrary order. You have to wait for the one behind it.
So it will wait until the first one is done before everything.
Yes. So the second dot then is going to wait for the first dot then to finish, and only then is it going to run the second dot then.
What if there was a third one? Would it wait for the second one?
And the third one would wait for the second one. The fourth one would wait for the third one, and so on. And that's all we have for our recap. So we did get through the first 4 days in 25 minutes. Yay. So today we have databases and authentication. And next week, stay tuned for some more exciting topics like sockets, deployment, and other advanced topics. Yeah.